Okay, we're going to be looking at, in this recording, chapter 5.1, multiplying polynomials. Poly equals many. Nomial means term or terms. So a polynomial is a many-termed problem. So we look at first how we evolved through the multiplication process. Initially, we start with a problem like 2 times 3 in elementary school. So that's going to be 2. This is the area model for multiplication by 3. That's 3 right there. Draw a rectangle underneath it. Okay, there's your area. Use your breaks. There's a break here, draw a line. There's 2 breaks there, draw a line. So you can see that there are 6 inside of here. So 2 times 3, in fact, equals 6. Now, as you moved into middle school, you had your pre-algebra classes, and some of the second one will also be at high school as well, but you had your pre-algebra classes where you had to multiply exponents, or multiply 2 numbers together to get an exponential form. And so this is going to be x squared. You know that by just going x times x, but here's what it looks like. There's x. There's x. Those are your dimensions, just like 2 and 3 were your dimensions here. And then you draw your rectangle, and that gives you x squared. You can see its shape is a square. Okay, then we have distributive property in evidence here, and you multiply the 2 times the x and the 2 times the 1. Well, here's what that looks like. You have 2. Let's move that. You have 2, and then you have x, which is a bit longer, and then 1. Draw your rectangle. This is the area model of multiplication. You use the break here to draw a line straight across. Use the break here to go straight down. So there are 2 x's. There's 2 right here. And when you multiply this, you can see 2 times x is 2x. 2 times 1 is 2. Again, this is just the evolution of multiplication throughout the grade levels. All right, now in algebra, which was your 8th grade year, and then again in your algebra 2 or 10th grade year, you're going to be looking at multiplying binomials. Again, these are polynomials, but because there's 2 terms here, we call them a binomial. So 2 terms x and 1, 2 terms x and 3. So terms, nomials, are always separated by addition or subtraction. Now, we're going to look at how this looks, and then we'll get the answer. So we have x. That's your dimension, and 1. And then your other dimension is x and 3. And then let's change colors so you can actually see it a little better. You draw your rectangle, nothing different from anything we've done before. You put your breaks in. And you end up with x times x, x squared. That's a little bit more like a rectangle, but it's actually a square. And then 1 times x, which is 1x or x. And then 1 times 3, kind of like a multiplication table, 1 times 3, and these are 3 x's. And then 1 times 3, that's this corner right here, is 3. So you end up with having x squared, and then you have 1x, or just x, plus 3x, plus 3. You need to combine like terms. You've got 1x and 3x here. That gives you 4x. You can't combine x squared with anything, so then we just bring that down, and you can't combine 3 with anything, so bring that down. This is the product. Product is an answer in multiplication of x plus 1 times x plus 3. So it's x squared plus 4x plus 3. Again, that is the product of these 2 binomials. Okay, we're continuing on with multiplying polynomials. This example is from page 224, example 3. The book has done it in one manner, but I'm going to show you a couple of others. The distributive property is what the book is showing you. The table method is a shortcut for the distributive property, and the FOIL method is pretty much also a shortcut for the distributive property. So let's go ahead and start with the distributive property since it's something you have done before. We have 2x plus 3 times x minus 7. I'm going to use a different color here. 2x is going to be distributed to x minus 7. So it's going to be 2x times x minus 7. Now we're going to combine that with, so I'm going to put a plus sign, change my colors, distributing the 3 to the x minus 7. So it's going to be 3 times x minus 7. So now we're going to have 2x times x, 2x squared. 2x, so 2x times x, 2x squared. 2x times negative 7 is minus 14x. And then we're going to go over here after we put our, let's put our plus sign in first. And we're going to go 3 times x, 3x. 3 times negative 7, negative 21 or minus 21. We're going to go ahead and combine like terms. 2x squared can't go with anything, so it's 2x squared. You have a negative 14x and a positive 3x, which is minus 11x. And then we have minus 21, which cannot be combined with anything. So the answer for this, the product is 2x squared minus 11x minus 21. That's using the distributive property. Now, a method I like a lot more, and it's not in your textbook, is where we actually set it up in a table format, because tables can frequently act as a great organizer for our work. So we've got 2x plus 3 times x minus 7. And this is a lot like the model. So I'm going to go ahead and quickly show you the model. You can see the model right here for multiplication is all forming rectangles. Now, here's what is so great about this. It really looks like the model. So you have 2x and 3. That's the left side of your rectangular array. Then you have x and negative 7. That's your other dimension. So it's not exactly like the model, but it has a lot of similarities. So we have 2, and it also looks like a multiplication table. 2x times x, 2x squared. 2x times negative 7, negative 14x. 3 times x, 3x. 3 times negative 7, negative 21. And then what is another nice feature is that the like terms will be diagonal from one another. So there's no problem finding those like terms. So 3x and negative 14x is negative 11x. So you end up with, inside the area is 2x squared. Remember, this is the area model of multiplication I'm kind of showing you here. And then you have minus 11x, and then minus 21. Exact same answer as you have here. So these are the same. Same answer, different method. So you're having some choices about what you're going to use. All right, now FOIL is another very popular method. This one is in your textbook. All FOIL stands for is first for F, O stands for outside. This is just a memory device. I stands for inside, and L stands for last. So it's just a little memory device for you. So I have students, when I teach this, write the word FOIL. It's just a reminder. You will eventually not write it. And so then you look at the problem. And so you look at the problem, you look at the first terms. So 2x and x are the first terms. So 2x times x equals 2x squared. And then you look at the outside terms. So 2x and 7 are the outside terms, or negative 7, excuse me, which equals negative 14x. And then you look at the inside terms. 3 and x are the inside terms, so 3 times x, which equals 3x. And then the last terms are going to be these two right here, 3 and negative 7. So there's your last terms right here. And 3 and negative 7 equals negative 21. Once again, you can see that these two are like terms. Negative 14x and 3x is negative 11x. Then you just simply write your answer. We've got 2x squared, negative 11x minus 11x minus 21. Again, same answer, different method. Now, I don't want you to do 3 different methods for one problem. You can either choose a method you like and use it consistently to remember, or you can try a few out on different problems. So for each problem, I only want one method. Now, the only thing you have to keep in mind, the table method will work under any circumstances, and distributive property will work under any circumstances. However, that is not the case for FOIL. FOIL only works for a binomial times a binomial. So 2 terms times 2 terms. So it's a great method, but it is somewhat limited. Whereas the table method and the distributive property can be used on any multiplying of a polynomial problem. All right, this is not in your book, but you need to understand what we're doing here and why the FOIL method is somewhat limited. So for this particular problem, the binomial x plus 3 is being multiplied by the trinomial 2x squared plus 3x minus 5. Now the distributive property and the table method will work when you have a binomial times a trinomial or a trinomial times a trinomial. So these 2 methods will work. FOIL will not work for a problem like this. And so here is what it looks like. X plus 3 is going to be multiplied by 2x squared plus 3x minus 5. We're going to use different colors. So you take your x and you multiply it by the 2x squared plus 3x minus 5. So x times 2x squared plus 3x minus 5. And then you take your 3 right here, and you also multiply it by the trinomial. But we're going to add those together. So plus, because you're going to combine them, 3 times 2x squared is 6x squared. 3 times 3x is 9x. 3 times minus 5, or negative 5, is going to be minus 15. Now, you are going to go ahead. I actually did all of that work for you. I should have had another step in there. Let me back it up so you can see it. Sorry, I should have had this step in here first. 3 times 2x squared plus 3x minus 5, which is then 6x squared plus 9x minus 15. Now let's go over and distribute on this other side. X times 2x squared is 2x cubed. X squared is x times another x is x cubed. Plus x times 3x, so 3 times x is 3x squared. And then x times the minus 5 is minus 5x, and then adding it. You look for like terms and put those together. So 2x cubed doesn't go with anything, so we just bring it down. But you have a 3x squared here, and you have a 6x squared here, which is going to be plus 9x squared. Then you have a minus 5x and a positive 9x, which is going to give you plus 4x. And then we have absolutely nothing to go with the minus 15. So that is your product. 2x cubed plus 9x squared minus 15. Okay, now your table method is really a nice one for a problem like this. You have your x and your 3 here, so x plus 3. And then you have your 2x squared plus your 3x minus your 5. You draw in your table, and you actually don't need the plus signs in. Let me take. Works like a multiplication table. X times 2x squared is 2x cubed. X times 3x is 3x squared. X times minus 5 is minus 5x, or negative 5 is negative 5x. 3 times 2x squared is 6x squared. 3 times 3x is 9x. 3 times negative 5 is negative 15. And again, you can see your 2x cubed. Your like terms are diagonally. 6x squared and 3x squared is 9x squared. And 9x and negative 5x is 4x, and negative 15 comes. Your assignment is this multiplying polynomial Schoolology. Do it on a separate sheet of paper.